Today we are breaking down Wolfcore Bank, a custom vulnerable machine built to show how a single weak web feature can spiral into a full server compromise. What starts as a search function becomes a database exposure becomes stolen credentials become privileged access becomes dangerous upload capabilities, and dangerous upload capabilities become code execution and full control of a remote server. That is a real reason of this lesson of this room. This is not about one magical exploit. This is about a vulnerability chaining the way real companies actually happen. Huge credit to Tom Thomas, our colleague who built this machine for us to learn from. Is really solid example of how realistic attack paths work, and is exactly the kind of lab that helps defenders and pen testers understand how breaches unfold in the real world. So let's get into it. First thing we're going to do is going to start off with an Nmap scan. This room simulates a vulnerable online banking application running on a Linux server backed by Apache, PHP, and MySQL. And what makes this room useful is that it mirrors the way real intrusion happens. An attacker does not always get everything from one single exploit. Instead, they get one small foothold, then another, then another. This is what makes this room actually valuable to us. Now, before we do anything malicious, first thing we want to do is become a regular user. We open the Wolfcore Bank application, create a new account, and log in. So let's actually begin with the first thing there. I actually just want to switch this off to do not disturb so I don't get notifications about my battery. So we review the application itself, and the first thing we want to do is sign up. So press Ruben at wolfcore.com, Ruben, and create account. Then we go over to sign in. So first, create a normal user account, log in, and browse around the web application. Once inside, we make our way into what's called the search functionality. So we'll look at that in a second. So let me log in, and my password is not right. Okay, right, great. So with a friend referral, I've got £100 in my account, which is great. Transfer services, log out. Now, transfer, that means we'll be able to transfer money from here to someone else, or someone can transfer money to us. Services, search our services is exactly what I'm going to be looking for. So the search functionality is this. Now that we're logged in as a normal user, we can start testing the actual search box. The first thing I try using is usually just one single quote, especially if it's anything to do with an SQL injection. So as we can see, this is not some magical hacking trick. It's simply a quick test to see whether the application might be placing my input directly into a backend SQL query. If the page breaks, returns blank output just like it has here, or behaves differently, that can be a clue that the input is not being handled safely. And once we see that kind of behavior, we move to what's called a union-based validation. The first payload I usually use, union-based wise, is union select null 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 null. So let's go back to it and try test out that first parameter. So we get ID, service name, description, and category. So we actually get some of the results, and it's still searched on the server base. At this stage, I'm not trying to steal data yet. I'm trying to confirm whether I'm successfully append my own select statement onto the application's original backend query. The reason I use null values here is because null is flexible and usually avoids data types conflicts. If this works, it tells me two things, two very, really important things. First, union-based SQL injection is probably possible. And second, the query likely expects 4 columns. So this first payload is all about checking whether I can control the structure of the query. Once that works, I move on to the next payload. Now I'm shifting from validation into information gathering. So in this section, I'll start integrating database. So As you can see, we've got ID Wolfcore Bank. Here, I replace one of the nulls values with database function. That asks the database to reveal the name of the current database being used by the application. Why does that matter, you ask? Because once I know the database name, I can stop guessing and start querying the scheme properly. That gives me the map I need for the next step. After that, I use this payload. So the next payload will be this. Union select table null information scheme tables where table schemes and then Wolfcore Bank. So this is where the search box stops being just a search box and starts to become a database enumeration tool. Here I'm querying information scheme tables. Information scheme is basically metadata about the data itself. It stores information about database, tables, and columns. So with this payload, I'm asking, show me the name of all the tables inside the Wolfcore database. This helps me identify interesting tables like users, account, transaction, admin, or anything else that looks valuable. Once I find an interesting table, in this case, the user table, which we have here, now I need to move on to this following payload, which is this one, which is union column null from information scheme tables users. Now I'm searching deeper for the users. Now I'm asking the database show me the column names inside the user table. This is important because before I can extract meaningful data, I need to understand the structure of the table itself. This step might reveal columns like username, email, password, role, balance, ID, and so on. So this is really about learning layouts before I start pulling back real data. And finally, once I know the structure, which we do here, I use the real extraction payload, which is the following command. This just shows on how much information you can pull out from just a search bar. And here we go. This is the impact moment. At this stage, I know union works, I know query expects 4 columns, I know database name, I know there is a user table, and I know which column I want. So now I ask the database to return email, username, password, and a balance directly. Email-wise, it hasn't shown me anything, which is interesting. So that means something to do with the command that I've sent needs to be altered. I won't even bother going through it. But if the data gets rendered back in the application response, then I've effectively turned a normal search feature into a data exfiltration point. And this is exactly why SQL injection is still so dangerous. A search box should return search results, not your entire user table. This is also where the vulnerability stops being technical curiosity and starts becoming a real impact. We're now exposing account identities, password hashes, and financial information. And once stolen data becomes usable access, the breach gets much worse. One thing you will notice that at all of these payloads, at the end, I use dash dash, space, and one more dash. Now, a lot of people will wonder why. This is a SQL comment sequence. The reason for this is quite simple. Once I inject my own SQL, I usually want to rest. I want the rest of the application original query to be ignored. So the comment cuts off whatever comes after my payload, and it helps reduce syntax errors. The lesson here is not just memorizing one payload. I myself usually have the SQL injection parameters saved in Notepad++ or Vim for me to return to. Or I do research obviously on Google, or I use AI to be able to help me create such accessible SQL injection patterns. SQL Map is the main tool that quite a lot of people use to be able to make this a lot more automated. The real lesson is that if users' input is inserted directly into a query without proper parameterization, and that second might be able to reshape a query entirely. And once that happens, harmless looking search features become a direct path into the application's most sensitive data. And this is where the breach gets worse, because the scary part is not just stolen data. So the next step is take the leaked password hash, save it into a file, and try to crack it. So first, now I'm going to look at, let's say, there's Bob, Joseph, John, Sarah Smith, Mary Doe. So, I mean, Tony has got tons of money here, 7,500. So we copy his salt and we'll go over to, we'll go CD into Wolfcore Bank, and then we'll do VI hash free, because I've already been testing this out, .text, and then I'll paste exactly this into the Vim and then save it, VI. And then I'll use John word list exactly like this to crack my salt, which I'd already done before. So if I go John dash dash show hash, and I'll do free instead. So I've got Tony has got the password hello, which is great for us. So I'll copy that. I won't even bother copying that. And then I'll go log out of my account, go to Tony and hello. Perfect. And we don't need to save that. So he's got £7,500. We can transfer some of his money, and then we can use the search functionality. And he's got something called a VIP portal. At this point, we recovered the valid password, and this moment it's the database database breach becomes an identity breach now. Because we're no longer just reading data, we're now becoming a real user inside the actual application. So next, we take the extracted username and recovery password. We logged in, and that's it. The user is compromised. Now is the point we move to the next weakness in the chain. After account compromisation, the next flow is transfer logic, and this part is especially realistic because this issue is not classic injection, it's what's called a business logic. This is a race condition. The application appears secure during normal use, but if multiple requests are sent at the same time, the state handle breaks down. So here's the flow. We've logged into the compromised account. We're going to go to account transfer. From this, what we're going to do is I'm obviously Ruben, and I'm going to send some money to me, and we'll do, I want to send, let's say, £400. We're going to go, we're going to get Burp Suite on first. We'll go over here, File, New, rename this to Burp. I like my tabs named Burp Suite. At the same time, while that's about to run, I'm going to go over here, settings, and manual proxy configuration fully on. Go back to this section here. Allow that to kick off. Next, start burp. Right, so proxy intercept on, and we are ready. So I go over here, transfer the money, burp catches the first request, and then we'll send that to repeater. In repeater, we can say that to username Ruben amount 400 to be sent. First, I'm going to create a group. Group 1 will be absolutely fine. Then I'm going to duplicate this. Let's duplicate it 20 times. I'll change this as well to 200. And here we're going to change it to send group in parallel. So that means it's going to send all these 20 requests all together at the same time. What we've done here, create a group, duplicate it multiple times, then now we're going to send these requests in parallel. The idea is that the application validates the balance but before it updates the state consistently, multiple requests are able to bypass through at once. So what I'm exploiting is not bad input sanitization this time. What we are exploiting is a timing flow in the business logic. And this is really important lesson. Security is not just about filtering dangerous characters, it's about state management, transaction integrity, and how the application behaves under pressure. A system can look perfectly secure in normal use and still fail completely the moment concurrent requests arrive. That is what makes race conditions so dangerous. So once the parallel transfer requests go through, we're going to log out of the compromised account, then go back to our original account. So let's see what actually happens here. So I'll send the request and we'll wait for the response. Response arrives with 200 OK, and in the proxy, we'll switch off intercept. We'll go on the settings again and we'll switch off the proxy as well and leave it on OK. Then we will go to logout and then we'll back in as Ruben again. There we have it. So at this point, we have £8,700 in our account transferred from Tony. So transferring, then we're going to obviously, now we want to be able to gain the VIP status that Tony had as well. Now this is a very interesting way of doing this. We're going to send a small amount to now the manipulated account and then refresh and revisit the dashboard. And at this point, we should be able to gain the VIP account privileges. So back to Tony, I'm going to send him, let's say, £500. Transfer successful. Now you're a VIP member. Perfect. Now if I go back in the dashboard, it seems like we have a new VIP portal. Perfect. So if I go into VIP portal now, actually I need to refresh this. VIP portal, it doesn't seem to be working. So let's log out of that. Go back in. Okay. VIP portal. Perfect. VIP status is now unlocked. And we now reach the dangerous feature in this chain. The VIP area gives us access to the document upload function. This is where a lot of real organizations get into trouble, into some serious trouble, because file upload features often look harmless from a business point of view. Upload a receipt, upload a document, upload an image. Nothing seems unusual about that. But if validation is weak, storage is unsafe, and or upload files land inside a web accessible executive path, that feature can become remote execution. So now we take advantage of that. The next step is to prepare a PHP shell with a callback IP and port configured. So inside my IP, we can now close burp off completely. Yeah, clear this away. ls. So inside here, I have what's known as a rev file, which is a PHP file, reverse shell. Now this one is from Monkey. I can't remember exactly the name of it, but the whole point is you guys find this yourself. So stated on IP 192.168.0.79 with a port listener on 4440, so I can just quickly check my own IP, which is correct. So that's already set up. So I can clear all of that. I don't need that information. Set up a listener LVNP on 4444. Go to the upload section, browse CTF Wolfcore PHP rev file, and I can upload the document. Now at this point, what happens, and I already know what the directory setup is as our team has built it ourselves, but usually a tool such as GoBuster or Deerbuster needs to be used to be able to find what active and live pages are actually accessible. Usually we use Deerbuster or GoBuster. For us, for what I'm trying to do right now, it would take us too long to find it. So I already know that the section it lands is on uploads. If the file lands in a web accessible folder and PHP execution is allowed here, triggering that upload, file gives us code execution on the server as the web browser. And this moment is where web bugs stop being just a web bug and start becoming operating system access. So I'm going to drag this. I'm going to drag the actual tab to the left side so you guys can see exactly what's about to happen. So we have the listener on the left hand side and we have the upload file. So all I'm going to do is literally click on it. And there we go. We have remote access control. So the shell has lands. Now it's all about moving to the web root and inspecting the environment. So we're actually inside now. So if I do ID, who am I? Oh, who? Okay, we exactly know who we are. So cd var www html. Okay, there. So we already are in this section here. We can even do ls. We've got a flag.txt. I'll allow you guys to actually review this. At this point, we've gone from a normal user account to full code execution and a web server user. And that alone would already be such a breach, such a serious breach in a real world environment. But we're not finished yet, because the final step is local privilege escalation. After landing on the box at the web browser user, the next goal is to move upwards on the actual host. This is another important real world lesson. Initial access is rarely the end goal. Attackers want root system, domain admin, or some equivalent level of full control. So first enumeration is SUID binaries on a system. So it'll be something like find dash perm dash u equals s and then dash type f2 dev dash null. And the command will show files running with elevated privileges. This is something that you will get used to doing when you come to the point of especially enumerating a Linux machine, because there's all sorts of areas you're going to go rattling through to try find all sorts of more information to be able to get privilege escalation. Now, perfect. In this room, Python is available as an SUID capable privilege escalation path. So the next command would be this: Python free-c. Then we do import os dot excel like this. And then we close that off. Then we do dash bin dash close that off inside. Then we do comma, and then we do dash p, close that off like this, and then that. Syntax error, so I need to have a review of that and see exactly what I've done mistake there. It's been a while, so yes, I see. Okay, I see what I've done. Python free -c import os dot excel, close, then that dash bin dash shut, and then close that off as well. And then you usually need decent concentration for something like this. Boom. Okay, perfect. If I do, we got to full compromise here, and there it is, the full system. Unfortunately, I don't exactly know what's gone wrong there. This is still a buggy machine. We'll have to give this a good review and understand what's going on with it. This is exactly why host hardening matters just as much as application security. Even if an attacker lands on a low privilege service account, weak privilege boundaries can turn that foothold into complete control of the server. So we step back and look at the whole room. The big value of Wolfcore Bank is not just any one bug by itself, it is the chain. A search feature leads to database exposure. Database exposure leads to credential abuse. Credential abuse leads to privileged application access. Privileged application access leads to dangerous upload capabilities, and dangerous upload capabilities lead to code execution. Code execution leads to host level privilege escalation. That is how real companies compromise work. Attackers do not always need one critical bug at a very beginning. Sometimes they just need one weak point, then another, then another. And that is exactly why realistic training environments like this matter. They do not just teach isolated vulnerability names, they teach how compromise actually unfolds. Huge credit to Tom Thomas for building this machine for us. It really is a proper hands-on example of how web application flaws, business logic issues, and Linux privilege escalation paths can combine into one full compromise chain. And that is why labs like this are valuable, not a glorification or glorified exploitation, but to help defenders, testers, and engineers understand how these attack paths work so they can recognize them. And earlier they recognize them, the sooner they can stop them before they become real actual incidents. If you want more walkthroughs like this, more custom labs, and more security lessons, please follow Wolfcore. And yeah, thank you so much for all the support. I'll see you next time.